So, so in this video, we're going to introduce the concept of couple moments. So couple moments are caused by if you have any rigid body. So here's our rigid body. And we have two forces that are equal and opposite. So I have one force here, and then we have another force going in the opposite direction here. And they're separated by some distance, which we'll call distance d. Okay, what this will do is it will cause the body to rotate, or it'll try to cause the body to rotate. Alright, in this case in a counterclockwise direction. Okay, so the reason couples are used in mechanical designs are they're used to try to cause rotation without applying any net force. So if you just want pure rotation of the rigid body, you would try to apply a couple moment to two coupling forces to it to generate that pure rotation. All right. So you can calculate the magnitude of this couple moment that we've shown on the left-hand side here by using the following equation, where the total moment is equal to the magnitude of one of the forces times the distance between those two couples. Okay, so d is the shortest distance between our parallel forces. All right, and then the direction. So m can be either positive or negative. So to determine whether it's going to be positive or negative, you need to use the right-hand rule for moments. So in this case, using the right-hand rule, we can determine that it was going to create a counterclockwise moment, and it would be a positive. This would be a positive moment. All right. So so you can also use vectors to calculate the moment of a couple. This is very useful, especially in 3 dimensions. So we can define our moment of a couple as being r cross f. So if we draw our rigid body, all right, it can be any rigid body. I'm just drawing an arbitrary shape here. All right, and we have a couple moment that's acting on the system. So let's say we have one force. I'll call this negative F, and then we have another force that would be going in the opposite direction. I'll call this positive F here. Alright, we can define our position vector at any point. Alright, so R may be defined at any point. Alright. However, what we typically do is we're going to take a point. We're going to start at one point along the line of action of one of our forces, and we're going to go to another point on the line of action of our other force. Alright, so we'll typically do this for R. This is what we'll select. Okay, so the reason we do this is we know that the moment caused by our couple is going to be equal to the R cross F plus R cross, I should put this as like R1 cross F plus R2 cross F2. All right. Now, if we determine the moment about, let me call this point A here. All right. R2 is going to be equal to 0. Okay. So this cancels out this whole other term, and we're left with just one cross product calculation. So typically, you'll start at your moment arm will start on the line of action of one of your forces, and it'll go to the other line of action of the forces because it makes your calculations a lot simpler. Okay. All right. All right. So everything else is just like you did for the moment about a point earlier. The only thing here is you have to define your position vector from one point, the line of action of one force, to the line of action of the second force. Right? And then you can calculate the total couple moment due to those two forces. All right. Um, so in mechanical design, you can take advantage of longer lever arms. So in this case, we have a man is trying to pull is trying to rotate this wheel, this valve stem, and what he's doing is he can, depending on where he holds the valve stem, he has to apply more or less force in order to cause the valve stem to rotate. So in both of these cases, he's generating a couple moment of 12 Newton meters, negative 12 Newton meters. All right. So any two systems that create equivalent moments are said to be considered equivalent couples. So the last step here is that if you have a rigid body, like the one that's drawn on the bottom of the screen here, where it has multiple couple moments. So in this case, we have two couple moments. We have one due to force 1 and we have one due to force 2. We can calculate the resultant couple moment using the following equation, where our resultant moment would be equal to the sum of all of our couple moments added together. Okay, so so for a couple moments, so for this case, it would be equal to, our resultant moment would be equal to the moment, couple moment due to force 1, which we'll label as M1, plus the couple moment due to force 2, which we'll label as M2. And then if we wanted, we could define our position vectors. So I can define a position vector R1 here, and a position vector here, R2. So we have R1 cross F1 to calculate M1, plus you can calculate M2, R2 times F2 to calculate M2. Alright, and that's how you could solve for the total couple moment due to multiple couples acting on the same body.